This is the sixth and final section of the linear transformations chapter, and here we look at the inverse of a linear transformation. So if we have a matrix M or A, as they've got here, that does some sort of transformation, then the inverse matrix will reverse that transformation. Reverse the transformation. So basically what it will do is, you know that you start with your points in the object, okay, and then when you apply your transformation A, you end up with the points in the image. So if you apply the inverse transformation, it will take the points in the image and take them back to the object, so it just reverses a transformation. That's what the inverse matrix does. And we also know from work we've done before that any matrix times by its inverse gives you the identity matrix. Now it doesn't matter which order it is, you will get the identity matrix. So the matrix A represents the transformation T. Given that T maps the point P with coordinates x, y onto some new points, 6, 10, find the coordinates of P. So let's write out what's going on here. So we apply this transformation 2, 4, minus 2, minus 5 to these points x, y. And what happens, those points end up going to 6, 10. Okay, so remember this is the matrix A. So if I apply the inverse matrix to the left of both sides, okay, then what will happen is these will cancel out, won't they? These two will cancel out, giving me what x, y is. So the first job is to find the inverse matrix. So what's the inverse of A? So we're going to find the determinant. So that's 1 over the determinant. That's going to be 2 times negative 5 minus negative 8, which gives me negative 2. Then we swap over the elements negative 5 and 2, and we reverse the signs of the 4, so that becomes negative 4 and the 2. So this should be 2 here. Right, so let's just work this out. So basically halving everything and reversing its sign. So I'll get 5 over 2, or 2.5, then 2 here, and both of these will be negative 1 at the bottom. So now xy, these original points, is going to be this inverse matrix times by the points 6, 10. Right, so let's work out what we get with that. Right, so you get 5 over 2 times by 6, which is 15, plus 2 times 10, so 15 plus 20 is 35. And then we get negative 6 minus 10, so we get negative 16. So these are the coordinates of P. So I suppose I should write down equals P here, so there's no confusion. Okay, now why did I call that part B? I don't know. Let's call that part A. Now let's move on to part B. Now before a part B, it says the transformation, or the matrix B, represents a transformation U. Given that the transformation T followed by U is a reflection in the line y equals x, find B. Okay, so the matrix B is the second transformation, so we write that first, and the matrix T is the first transformation, so we write that second. And when we do that transformation, we're told that it's equivalent to a reflection in the line y equals x. Okay, now we should be able to work that out quickly. So let me do my little things again like this. So a reflection in the line y equals x, which is a line like that. Where are those points going to move to? Where the 1, 0 moves to 0, 1. And the point 0, 1 moves to 1, 0. So that's basically what those two matrices do. It moves it to the point 0, 1, 1, 0. Now, if I apply the matrix, the inverse of A, to the right of both sides, so at the end there, and to the right of this, what will happen is that the A and A inverse will cancel out like this, leaving me with the matrix B. So to find matrix B, all I need to do is to multiply the matrix 0, 1, 1, 0 with the inverse of A, which I've already worked out, 5 over 2, 2, negative 1, negative 1. We'll multiply those out and see what we get. So I will get negative 1 here, and then negative 1 here as well. In the bottom row, I'll just get this 5 over 2 or 2.5, and then I will get 2 here. So this matrix here represents my matrix B. Okay, you should now be able to do exercise 7F on pages 148 to 150. So just remember that an inverse matrix reverses a transformation. So inverse matrix reverses a transformation. That's the first thing. And just remember, we did this before, that any matrix times its inverse, they cancel out, giving you the identity.